Hi there, and welcome to the very first episode of Retro Brewhouse, a podcast about making video games for vintage and modern retro systems. I'm Matt Heffernan from Slithy Games, and you may have seen my YouTube channel where I create demos and games for the Commodore 64, Sinclair ZX Spectrum, and many other retro computers and gaming consoles, along with modern retro machines like the Commander X16. I also make tutorial videos to evangelize the hobby of retro game development, using modern tools to work on 8-bit and 16-bit assembly language. Every episode of this podcast will feature a panel of my fellow retro game developers, and with me today are Scott Robison.
Hello.
Tom Wilson.
Greetings.
And Zero Byte.
Hey.
Hi guys, thanks for joining me today. First episode will be mainly introduction to myself and the panel, and we'll talk about our backgrounds and how we came to retro game development and what we have created and are currently working on, and most importantly, why we do it. Let me introduce myself in a bit more detail. So I've been programming for about 40 years now at this point, and I haven't always been doing sort of the game development. I've been doing more professional software development, and especially for the last few years doing more things on the management side. I kind of call myself a PowerPoint engineer because I'm developing slides, and rather than developing code so much in terms of what people pay me for, than talking about the work that other people are doing. And as a result of that, I've become more of a technology communicator. And I've taken some of those skills and then pushed that into YouTube now to develop my channel, where I am talking about retro game development and specifically about how to do development on 8-bit systems, 16-bit systems, and especially using assembly language, which is sort of a lost art now. When we talk about these 8-bit systems, they are really made not to use BASIC. The BASIC interpreters that were put on a lot of these old systems, they were made for people with zero to very little programming experience to be able to do basic things, just to get their feet wet and kind of learn what they're doing. The real meat of that computer, the way that any sort of commercial games would work, of course, they weren't with BASIC, they were written with assembly language. And so I try to sort of lift the veil on that, help people understand what they're doing. And so in the progress of doing this, I've created a bunch of games. Some are more finished than others. Sort of the first big game that really got my this current endeavor called Slithy Games going is a game called Chasefault for the Commander X16. And if you folks aren't familiar with the Commander X16, you might be familiar with a YouTube channel called The 8-Bit Guy. And this was a machine that he had first proposed, gosh, it's almost 3 years ago now, that on his YouTube channel, very popular, one of the most popular retro channels out there, over 1 million subscribers. And he had the concept of a dream computer based on his initial experiences of having a VIC-20 and later a Commodore 64, and the immediacy of using a machine like that. And I found that also very appealing. So I started following that, and then he had a couple follow-up videos to that. The second video after sort of launching this really kickstarted the community, and that's in fact how all of us here ended up being part of this podcast, is because of the Commander X16 and becoming part of that community. And some of us longer than others. I've been there pretty much since like mid-2019. And by the time that second video came out, where there was like a partially working prototype, and it looked more like a real project, I went ahead and started really playing with it in earnest. And my first demo for that, in fact, my first sort of retro video game content on my YouTube channel, which had a very different purpose up until then, was a sprite demo. So I was figuring out, well, let me see if I can get sprites to work on this Commander X16. It has for an 8-bit computer, because it's based on the 65 CO2 processor, which is very similar to the processors on the Commodore 64, Nintendo Entertainment System, the Atari 2600, the Apple II, just so many different systems use this instruction set architecture. But this was like a very high-end graphics system on it, still using this old processor. So I was like, all right, let's see what it takes to get a sprite to move around. So I created a demo of a little PacMan sprite, just going around and eating the text that was on the screen. So you could like
I remember you talking about that when you first got that out there.
Yeah, and the funny thing is, back then the sprites weren't even working right in the emulator.
No, I mean they weren't. They were pretty primitive. They weren't feature complete yet, but it was enough that with a basic program, that first program I did was in BASIC, because I hadn't done 6502 assembly yet at this point. I had done other 8-bit assembly languages, just not 6502 before at that point. And so I was with BASIC able to define a PacMan sprite and have it go and chomp all the letters off the screen. So if you did a code listing before, you'd fill the screen up with basic code, and he could just eat all the code.
I remember that thing.
And then I did another demo after that where I did the ghost monster little sprite, and he would go around, and rather than eat the characters, he would haunt the characters by changing their colors to be sort of a gray on pale blue as he went by them, regardless of what their color was. And then you could hit a button, and it would change between the 4 different colors of ghost monsters as it would go around the screen. And so that kind of one thing sort of led to another, and it's like, well, I started figuring I'd use these sprites. Now I'll build a tile map to make like a PacMan Maze. And here now I have Pac-Man and these ghost monsters. This is turned out pretty nice. And eventually I said, well, I'll just make a Pac-Man game. Why not? It wasn't the first time, actually. I'd made like a Flash-based Pac-Man game once upon a time. But it's like, well, I think now that I'm starting to learn 6502 assembly language, I think a good thing to do would be a well-known problem, which is how to make a Pac-Man game. It's a very simple game. The AI to it is dead simple. And so just implemented that, initially just using Pac-Man style graphics, but eventually that evolved into, well, I'm going to create my own concept, because I don't like Pac-Man on its own is kind of boring to me. I'm a big fan of Legend of Zelda. So I want to have the concept of being able to choose your own path through the game and strategize how you want to be able to get from the starting point to the end. And so I create the concept of having sort of lock and chase or Zelda type keys and locks, collecting keys, and then unlocking doors to go from one level to the other. And then eventually adding in this other skull enemy. And so that game became Chasefault, based on an actual crypt in Barbados that is haunted, or haunted, according to allegedly haunted. So there's that's the local superstition, is that it's haunted and that people go in there and they get scared and run out. And so I figure I'd have this pith helmeted, ignorant adventurer going in there. It's like, well, I'm going to collect these treasures that I can find in there. And of course, the ghosts are just trying to kill him at every opportunity. And that's how that worked out. And that sort of led to all these different other sort of games I was coming up with for first the Commander X16, and then branching out, showing these demos on YouTube and getting traction with them. And eventually that sort of blossomed into this little cottage industry of having retro game development based YouTube videos that other people seem to enjoy. And I started getting subscribers, and I was like fielding questions on Facebook and Discord and forums about like how to do different things with the Commander X16. Eventually it's like, well, I'm getting tired of answering the same questions over and over again, so I'm just going to make a video that explains how to do this stuff. Next thing you know, I have a whole series dedicated to teaching folks how to do 65CO2 assembly language, and then using all the parts of the Commander X16. And now that's evolved into doing Z80 assembly language for the Sinclair ZX Spectrum, and creating games for all these different things, creating an Atari 2600 game. It's like an Alice in Wonderland type game. I've got a game for the ZX Spectrum I'm working on that is a variation on Puzzle Bobble. But then my other big project is with the Commander X16 is an adventure game engine called XCI, which is short for Extremely Compact Interpreter, and very similar to Sierra Online's SCI Interpreter or LucasArts Scum sort of adventure game engine, so that I could make a game like, say, King's Quest or Maniac Mansion or Myst, something along those lines, a puzzle-based adventure game. And so I've made a few games using that engine, and the basically the AAA game that I'm creating for this engine is called Civs Quest, and it's an adventure that a guinea pig takes upon escaping her cage and getting out into the world and finding her place in it. So that's the sort of the big game on the horizon that I want to be able to get out there and actually have a real commercial release for on the Commander X16. So that's where I'm at. That's what I'm doing. So let's move on here now to Scott. Let's tell us a bit about yourself and what you're working on.
What I am and who I'm doing. Okay. So I'm Scott Robinson, of course. I work as a C++ engineer, but mostly I've done a ton of different languages through my career. But my day job has been Linux development with C++ for the last 3.5 years now, and then going back to the dark ages of DOS and Windows programming and so on. I got involved with this community about a year ago now, just over a year ago.
You're a newcomer.
I was actually on a short-term disability from work, and I was literally in a situation where I could not work. I mean, they had to lock me out of the computers because there was an insurance plan in place and all these other things. And I was really, really bored. So I started watching YouTube videos, and I came across the 8-Bit Guy. I found his videos about the X16 and learned about the community, and I just kind of jumped right in. I've done some game development. The most notable thing that I've done was a port of Attack of the Petsky Robots for the Commodore 128. Did that in cooperation with David Murray.
Yeah, and that's really nice too. In fact, David on the 8-Bit Guy video, his YouTube channel has highlighted that game, and it's really an excellent game. You don't see games like that for the Commodore 128 too often. People just play Commodore 64 games on it, but it really is a great example of how much more advanced the 128 was. So yeah, really kudos on that.
Thank you very much. And it was a great experience because I haven't done a lot of game development. I worked 25 years ago for Acclaim Entertainment. I escaped, so I'm better now. But I worked on some things that didn't get much promotion. There was a game called Stratosphere where you flew these float stone fortresses through the sky and attacked other float stone fortresses. It's about as good as it sounds. In any case, I've done the Petsky Robots port for the 128, and then in talking with David about it, we decided to give it a shot. There's been a lot of talk in the community lately about the games like Sonic that can be run on the 120 or on the 64 with a RAM expansion unit. So we decided to give it a shot, and so we wound up porting the Commodore 128 version back to the 64 using the REU because we needed more memory to begin with, but then the DMA allows us to very quickly blit the tiles onto the screen. It's not doing as well, I think, mainly because the market was already saturated for the Commodore 64 version of Petsky Robots. One thing that I'm planning to do, though I haven't actually started yet, is do a Planet X2, X3 style game for the Commodore 128. So
be starting from like the Planet X2, like where you have the Commodore 64 code base already, or just starting from scratch?
I have the code for the IBM version, the Planet X3. I'm going to see what I can do with that to actually maybe bring the extra features that X3 has back into the 8-bit world, because we have more memory, a faster CPU, in theory, things like that. One interesting thing for me is when I first started playing on the X16 emulator, I've never really been a huge game developer. I mean, I've worked in game development before professionally. I've got a couple of published titles, but for me, making the game is far more fun than playing the game, right? So the first things that I did when I first started playing with the X16 was trying to create tools to kind of bootstrap the process so that
Mm-hmm.
I created a tool called Basic Preprocessor that allowed you to write text files with just some sort of, pigeon markup. So you didn't have to use line numbers necessarily. And then it would read and parse all those lines and generate a complete basic program for you. My thought had been to do that and then write more basic tools to have a very simple, slow, but simple editor, and then eventually lead up to a basic compiler that would allow me to compile all of those things into 6502 assembly language, but having started with that basic foundation. That's still something I would like to play with at some point in the future, but that's not nearly as interesting to most people as I
I've gone
do
down
like
that
the
exact
tooling.
same chain of logic.
Well, I think the greenfield nature of the Commander X16 is one of the interesting things about working with the platform because, you can read the docs and it's like, these are the formats for everything. These are the addresses of the registers, but there's no tools to make anything. Some people upload some Python scripts that can take PNG and dump it out in the format. Then, there's something, and it's like, yay. But other than that, it's just totally, you have to do everything.
Yeah. I had to create a whole game engine just to make the kind of game that I wanted to make. And but then made it open source so that other people can do it and they can get out ahead of that and take advantage of my work, which is why most of my stuff I just make open source and free and open source. And it's like, here you go. These are the tools. The tools that I make are useful enough for other people. You go ahead and use those tools, and then you can create your own thing out of it. Because when you're starting from scratch, there's it's a big lift. All right. Well, thanks, Scott. Let's move on now to Tom. Let's tell us a bit about your background and so forth.
So I'm Tom. I am a software engineer for one of those big companies you will have heard of. Not that one, the other one. I bought my first computer when I was 10 or 11 years old. I was in 6th grade. This was when Commodore, literally the 64 and the 120 or the VIC-20 had just come out, and my library at my school suddenly had like 10 tables with computers on them. There were probably 30 computers in there. And they were going to start teaching a computer class the next semester. I sat down for about 20 minutes with a VIC-20 and the programming guide, and I was hooked. I went home and I told my parents, I got to have one of these. And they said, well, there's a load of horse corrals out in the backyard you can clean out, and do that for a couple of months, and you probably have enough money to go get one. That's exactly what I did. So I've had I've had the VIC-20, I had the Commodore 64, I had the Commodore 128. That was a Christmas present in about 1985 or so. And then I shifted over to the DOS world in college because to write C code, you pretty much needed a PC at that point. As much fun as DOS and Windows and all that stuff is, there's definitely something fun about coming back to the old-fashioned text-only screen. And I think my favorite computer I have right now is actually my Pet Mini. And I got the kit that you have to assemble yourself. And, I spent 2 evenings just sitting here soldering, and then it didn't work right. So it works, but there's a video problem. So like Scott, I'm interested in tooling and support projects more than like making a game or something. To tell you the truth, I'm just not creative enough to come up with an original game idea. I've watched Chasefault evolve, and I'm like, ooh, that looks like fun. But then I'm like, I sit down and come up with my own, and I'm like, let's make another Star Trek. And literally, the game I have most complete right now is literally another Star Trek written in Quick Basic. I just took Mike Mayfield's Star Trek and I stripped it down, and I'm building it back up from nothing. I mean, every line of code is mine, but I'm taking that idea, and the idea was I was going to build it in QB, and then I was going to downgrade it from Quick Basic using QB64 on Windows to QB on DOS, and then from there down to Commodore 128 with 80 columns, to the Commodore 64 with 40 columns, to the PET 4080 with 40 and 80 columns but no color, and have all these different versions of the same program that you could download. It would literally be the same program, but you could then go through and see how modern programming applies to older platforms, because that's part of it. Is it's going to be literally taking as modern principles as I can and then encoding those in Legacy Basic, Basic 2 and Basic 4 and all that good stuff.
Yeah, I think that's a lot of the big appeal, is that it's so much fun to do it now because we have all of these modern tools at our disposal. Yeah. It's so much easier, just the physicality of writing code and the process to have emulators running on these fast modern machines and just being able to just dart stuff off and make it work. It's just everything we had ever hoped for back when we were having to actually punch things into those little VIC-20s back in the day.
And you actually have inspired me, Matt. I'm still looking for a 128D, and I have a specific thing that I'm looking for in mind. I'm looking for the plastic case with the little feet and the original 128D. If I get my hands on one of those, I'm going to send you my 128.
That would be so awesome. I would really appreciate that.
It came to me for free, because the woman that gave it to me knows that I love these older computer stuff, and she actually literally texted me the night that I was just about to spend a bunch of money to buy one on eBay.
Oh,
and
wow.
get a text at like 9 o'clock at night going, "Hey, I'm going to be down at my storage unit tomorrow cleaning out my stuff out, and I'm moving to France. Do you want this old Commodore 128?" I'm like, "No, just throw it away."
My arm.
She had already gotten rid of the monitor because she had the 1802 monitor, the one with the dual modes. But so what I have done since is I have Texelex. I have their RGB to HDMI converter. This works perfectly with the Pet Mini and with the 128.
Mm-hmm.
And I have a CC, I think it's called CC GMS converter. Mm-hmm. And those work. Oh, that is wonderful. Those are wonderful tools for running 8-bit stuff on modern hardware. Yeah. Anyways,
big shout out there to Kevin Williams from Texelec.
Texelec, yeah. Kevin is really good with that stuff. And also, this is my high-tech mechanical keyboard. Texelex PCB keycaps from Adafruit, backing by me. You can see what's my engineering and what's somebody else's. That goes on my pet. I don't have anything out that you can download and check out, but I plan on adding some more things to the ecosystem. I want to add I want to add a file manager so you can copy files back and forth, things like that. I'm working on a menu program, tooling, and the kinds of stuff that's fun to develop, but not necessarily fun to play with. Mm-hmm. I'm also the webmaster for the forums for this Commander X16 website right now, along with a couple of the other guys. Scott is on the board, and we are, we're taking care of that, acting as a custodian for the community for when David finally retakes it and launches the system. In the meantime, we're migrating the forums over to new software for all you guys, and that is mostly complete. We'll talk about that later.
Even if you're not creating a game, you're obviously creating a lot and stepping up. When we've had some folks that were running the Commander X16 community from the website and forum perspective, and that's where a lot of the activity has been. Of course, we have the unofficial Discord, and now the actual quote-unquote official website has now also become sort of an unofficial fan gathering at this point. As David Murray, the Apic guy, has his own separate website. In fact, he had taken down a forum site that he shared with his brother, Mike Murray, the Geek Pub guy. And they have their own podcast too, Geek Bits, if you want to check that out. Hopefully folks subscribing to that will maybe find this podcast too soon. And they actually had this collective forum that was fairly popular, but they ended up taking that down in favor of the Commander X16 forum because that was the most active part of that forum.
It seemed to me there was a gap, but David Murray 2 went down, and then Perry Fractic stepped up and said, "Hey, we want the community wants a dedicated web forum and not just to use Facebook." Yeah. And props, all the love I can give to Perry Fractic for setting that up. Him and Matt Grandis, and obviously Perry Fractic has other irons in the fire, and we all totally support him and everything he's doing because he's awesome and his stuff he's doing is fantastic. Yeah. So if you of us stepped up and said, "Hey," and literally it was like a passing comment in another thread, and like apparently 5 of us just had messaged him independently, and he goes, "Hey, all you guys, I'm consolidating all this to one message. What do you guys want to do?" And 3 of us said we have enough time and energy to be to do these jobs, and the other two were like, I'd love to help. How about I be moderators? and everybody found a niche where they feel comfortable. And we're gonna have some developments coming up. We're gonna have a small fundraising campaign because our costs are modest, but they are not zero. We'll be switching over to the new website real soon.
And I think folks listening to this also, if they're finding this podcast either through my channel or through Facebook or Twitter or something like that, if they're not finding out about it through the Commander X16 website, they can go to commanderx16.com, and you can find there in the forums the discussion and the outreach there, and we'll have information on there if you want to support with your dollars the upkeep of that website. We have the opportunity to do that, and if you're not already engaged in that, that is also the main repository for all the software for the Commander X16. So that's it's a good thing to have, just to have everything all together in one spot rather than in like everybody's individual GitHubs.
Use your GitHubs. Post your source code and keep that stuff public. Where it's accessible. Before the forum, we were using a wiki to do it. I think the forum's a better place to collect it. If you guys are on Discord talking, if you guys are on Facebook talking, come to the forums. Discord is great for chat, but for long-term conversations, so much content just disappears. Out of Discord, out of Facebook, because it gets scrolled. It scrolls away, and we'll never ever find it again. So if you guys have that same conversation over here in the forums, 2 years from now, 5 years from now, 10 years from now, it's still there. You go over to Lemon 64, and there's conversations there that are 20 years old that you could still archive back to. Okay, maybe not quite that old, but there's stuff from way back. The first version of the forum you could still go read.
Well, I have those user groups where I have stuff from the early 90s. It's still on there.
I have some archived news groups from the 90s. I have stuff from my first computer with 3.5-inch floppy drives floating around on my hard drive somewhere.
All right. Well, thanks, Tom, for all that and for all your support there with the community. Let's move on here now to Zero Byte. Can you give us a little background on what you got going on?
Hey, I'm Zero Byte, and I'm actually not in the programming side of things with computers for most of my career. I'm actually a network engineer. I was started off pretty much as a gamer. As a kid, I was addicted to gaming. If I had every quarterback that ever went in an arcade machine, I could probably retire right now. Who knows? But I did like to program as well. My first computer was my mom got me a VIC-20, and I very quickly exceeded the memory with it with a very poorly written BASIC game. I liked Dragon's Lair at the time, and I was making like a text adventure version of Dragon's Lair, and there were no loops, there were no data tables. It was just linear, right, as you went, and filled up the RAM. And so it burned out something, and Mom had to return it, and she decided, since I filled it up already, she upgraded it to a Commodore 64, which is probably the best thing that could have happened to me in that regard. And I wrote a few things in BASIC. I never could do anything in assembly. Assembly was kind of like this witchcraft that me and my friends is like, ooh, it's assembly, ooh, sort of thing. Through the years, after I got into the PC side of things, I did take some Pascal in high school, but eventually, the BBS world kind of pulled me in, and the internet and everything, and that's what led me on to the career path that I'm on. And I did a lot of my programming in that realm is more like scripting, bash scripts and stuff, things to check that processes are running, that networks are reachable, and adding new customers to the web server. And having been in programming in college, it did kind of give you some good things. And most of the programming I ran into that ended up being like exactly like all the problems I gave you for homework. It was like input these 5 things and then output this, or read this text file, transform these 12 lines and spit this out. In fact, one time they needed something to transpose from the output of our billing system to the batch credit card processing thing. And I was like, this is exactly like a programming problem. I wrote a Pascal thing that did that, and that was what did our credit card transactions and everything. So I've pretty much been in the ISP side of things most of the way, and big into gaming all along. And as retro started to come up on the internet, and a lot of people, like Dave was one of my early ones when he started explaining how Planet X2 worked under the hood in the memory map, and his strategies for different things. And he was kind of scratching the surface of the technical side of things. And then it was down the rabbit hole you go, you get deeper and deeper, and the next thing you know, you watch 48 hours of Ben Eater building a computer circuit by circuit.
That's probably the best
So,
YouTube content ever, is Ben Eater building
oh
those
yeah.
computers on breadboards. I love it.
And I said, I now know how a computer works after watching that. And the other thing that got me here was it was actually an iOS game called The Human Resource Machine, and it's a puzzle game it's essentially assembly language, and it's all themed and has their quirky art style and tongue-in-cheek poking fun at corporate culture and all that kind of stuff. But I realized about 6 or 7 puzzles in that like this is assembly. And when I finished the game, like the final puzzle is to do a full-fledged sort on the data. And their assembly, I was doing this and I said, well, maybe I should go try something on the Commodore, So I was like, I now possess the skills. Also watch some of Michael Stiles like Ultimate C64 talks, and after you watch it about 8 times, you can absorb it, because it's if nobody listening's ever seen that content, he hits about 300 slides in less than an hour, and he goes very deep into each one of those slides, but it's very fast.
For folks that don't know Michael Stile, he is the main developer of the kernel for the Commander X16, and also wrote the 6502 emulator that is the basis of the X16 emulator. So he's definitely the one who's and thankfully lately has been re-energized to get new versions of that put out.
And
New
I
one
think
just today.
he's one of the more approachable people from the inner circle of devs, in my opinion. Maybe that's just because he hangs out on Discord, but if you come up with an idea, he's very gung-ho about it, and usually he'll say pull request. But it's not like well, if you're so smart, make a pull request. It's like it's like a nice way to say, well, go do it. I'll accept it. It's encouraging. And
That's a
you
great
know
idea. Let me know when you're done.
yeah, exactly. And spoiler alert, I actually have some code in the X16 kernel myself. But so after playing that game, and realizing that I sort of had a grasp on how to do assembly, I decided, you know what? I pulled out an emulator. I went and bought a Commodore 64, and I said, I'm going to write a game. And I knew a thing or two now about like how rasters worked and sprite registers, blah blah blah. But I've never done any of it. All my code's been Bash or a little bit of light PHP, some Perl, things like that. But so I sit down and pull out the Commodore Dev Tools, and I decided to make Flappy Bird for Commodore 64 because, and then I made it for X16. It looks like I'm just the ultimate Flappy Bird fan, and I'm not. I mean, it's fun, and I've gotten pretty good at Flappy Bird over the course of developing it. But the reason I picked that game was because it's a very straightforward game. It doesn't have a lot of moving parts internally. There's very simple rules. You have to implement scrolling, you have to implement a sprite. It was a good first step for me to pull up the blank screen and start typing assembly from absolute scratch, knowing like nothing. And then I found that, the 6502 is actually easier to write for than the human resources machine because you had more registers and you have more branch conditions, and like you can increment X and things like that. And I was, of course, being new to it, the thing I found hard to shift over was I had taken, some formal programming in college, and they drill in all that structured code. No, all code has to start at the top, flow, and end. There's no such thing as an exit. There's no such thing as a label go to, and never use global variables. And in a system this small, like they're everywhere. All
Yeah.
those sins are you have
They're
to do them.
virtues. They
You know,
become virtues. They
and
become necessities.
oh yeah, and I found that like, and I imagine if I went back and looked at my code again for that Flappy Bird for Commodore 64, and it's not the one that you've seen videos for on YouTube. That's somebody else's Flappy Bird. If I went back and looked at that code, I know I'm going to cringe because I still had that like if then else, do this or do that type mentality, and assembly doesn't have time for that. It just has to, crank a wheel and indexes go through tables, and then somehow magically a game's on the screen. That's how you know you've done it right, is like there's no logic in it whatsoever. It's just a bunch of Turing machines that make the thing happen. But my goal was not to make the ultimate game for the Commodore 64. It was to make a game for the Commodore 64, and one that I didn't have to make AIs and non-blocking routines and balance stuff. But I did give myself enough challenges. Like I did raster effects to draw the screen with sprite multiplexing, and I had to dance around with the bad lines and things like that. So I did get a lot of experience out of it. When I switched to the Commander X16, I'd never written a multi-file C project before, so I said, well, I guess it's time to write Flappy Bird again. I did that in C, and it's been recently run on the real hardware Waveacle's got.
And for a bit of
One thing is,
context, Waveacle, he's another part of the community. He's active on the Discord and the forums. And so recently the Vera, it's this FPGA based daughter board that does all of the video, SD card interface, and does part of the sound capability. Is all wrapped up in this one FPGA package, and that the creator of that, Frank Vandenhoef, actually open sourced that, and so now folks are actually waiting for the real Commander X16. If they want to get their own hardware, folks are sort of homebrewing their own version of it before the real one ever comes out. So
that blows my mind. That dude just sat down and went, "I'll just build my own."
Yeah,
I'm tired of waiting. I've got chips. But,
I got some chips. I got a breadboard. I'll take care of it.
Yeah, but one of the things is a lot of people in the community are SID worshippers. They're just like, it should have 12 SID chips in it. 200 SIDs. And like, who needs FM? FM's terrible. I hate FM. And I'm like, that's because most of you, your experience with FM music's been like stuff that was written for the Roland MT32, and then whatever the MIDI program happens to dump out for ad-lib with the most boring, bland general MIDI patches. Fine. And if you don't like the music, go buy a Roland. That was sort of the thing. And so the music and sound for ad-lib in the PC world is what most people think of FM. And I think of FM music, and I think of all these Japanese arcade machines that the music was super awesome. Ghouls and Ghosts. I like Black Tiger and all that. And to me, that's integral to the 16-bit era sound, and I think that a lot of people are underestimating the Commander X16. To me, it's more like a 16-bit computer with not quite not a 16-bit CPU.
Yeah.
But as far as like graphics and sound, and when I say 16-bit, it's more the marketing sense of 16-bit. Back then, it could have 128 bits, but none of it mattered. It wasn't really how wide the bus was or how many bits were in a register. It was how many bits of cool it had, and Sonic had blast processing, and so I felt like FM music really needed a cheerleader or two on there. So I've been beating the drum for that, and I just really dug through all the specs, and I've recently gone off into making a sound library and a sound tool chain for the Commander 16 because of the greenfield nature. If you want to sit down, it's one thing to read that this register makes this beep, but you can goof around, but it's a long stretch from being able to make stuff. You don't have the whole tool chain. And so I thought, like, if everybody started agreeing on the format that music takes, then it would be easy for some people to say, hey, I'll make a music editor. And somebody else is like, hey, I'll make a game with some music in it. And then this guy's music editor works, and somebody else can write music with the music editor, and then it'll springboard the thing. And I've worked with a few people that have used Z Sound a little bit. That's what I call it, is Z Sound, and I've got a GitHub repo. I need to make some more videos showing some more of the things because it's a little more mature than it would seem on the music side. Recently, I've been faced with getting the PCM playback a little better because it was getting buffer underflows, which means crackle and hiss in your digital audio playback. And
yeah, I think that's really the cool thing about the X16, and that really Z Sound is helping to push forward, is just how capable the X16 is on the sound end of things. That it's really, even for in the PC world, until PCs really started moving towards just purely high bitrate PCM based audio. In terms of programmatic capabilities, programmatic sound generation, and FM synthesis, you didn't have that unless you had a really high-end sound card on a PC. And you're going to have that with the X16 just by thanks to it's the magic of the FPGA being able to have that programmable sound generator. And then also you'll see why PCM wasn't a thing in the 8-bit era, because you just can't push
CPU.
the bits.
Oh yeah, it takes, I think, like if you run the Commander 16 at the full 48K on stereo 16-bit with my blitter in there. It takes about 45% of the raster time just to grunt the bytes into the FIFO.
But thanks, ZB, for all that and for everything you're doing, and everybody here. Thanks for everything you're doing with all this stuff, and it's really cool. So I think now's a good time to move on to our next topic of conversation, which would be our first time. And no, it's not that kind of podcast. This is our first time programming on a computer, about the tender age where you first got to not just touch a computer, but actually make it do what you wanted it to do. I'll start in my particular case. My first experience ever using an actual computer that wasn't, say, an arcade video game machine or like an Atari 2600 or something like that would have been an Apple II. That's what our school had. I grew up in the United States. Have been living here my whole life, and for us, Apple was really gung-ho about getting their computers into the hands of every school children, not to take home, but to have available for them in the classroom and be able to be exposed to computing that way.
If I recall, Apple literally gave an Apple II to every school in the country.
Yeah, something like that. And they also, on top of that, had a very steep discount for schools if they wanted to have additional machines. So my school went all in. At my elementary school, we had about 8 Apple IIs, I think, and I think they were original Apple IIs. They might have been Apple II Pluses, because this was around 1982 or 83 when I first saw them there. And so wheeled into the classroom at one point was this Apple II with a cassette deck. It did not have a floppy drive. It had a cassette deck and a monochrome. Pretty sure this first one that I touched had the green phosphor screen. And it was one of those edutainment math type games. And it was obviously for math, even though I was, at the advanced age of 7 in second grade, the game itself was not challenging at all. It was a very basic game. It was like, the game's not much, but this is really neat. Having a computer with a keyboard, this is not just a PacMan machine that I can plug quarters into. I can actually do something that's a little more interesting. And then the next year, I had the opportunity in a class to be able to do actual programming on the Apple II. And so what we had was not BASIC, but Logo. And for those who aren't familiar, I would imagine most folks that are listening to this podcast know what BASIC is and how BASIC was used on pretty much all APIC computers, including the Apple II. There was a version of BASIC that came with it, and then different versions of BASIC came out that were coming on a floppy drive. And we did have floppy drives by then. By 1983, we had the floppy drives. One of the floppies that we got was Logo, and you stuck it in there, and it just had a prompt. You would do what were called turtle commands, and you had this little delta-shaped thing. It looks sort of like the head of a fountain pen, and you would give it instructions, very simple instructions, like forward 10, left turn 90. There you go. So Tom's got a little picture of what that looks like. And you could draw shapes by saying, all right, we're going to go forward. We're going to put the pen down. We're going to go forward a bit more, turn so many degrees to the left or the right, keep going forward, maybe go backward, and draw shapes. Then you could do like more curved shapes. And ultimately, you could develop this fancy picture. That was my first experience in programming. It was the immediacy of being able to give the computer a set of ordered commands and see that take effect in drawing a picture. So it was, of course, a slow process to write in all the commands, but then when I would just have it go, it would fairly quickly draw it. Now, being an Apple II, not a horribly fast computer, you would still see the turtle. It happened. It took a few frames of video for it to actually move around and do all the things, and you'd watch it actually execute this in real time. But it was certainly faster than I could take an actual pen and draw stuff on there. And so that was really cool. And I got to take that a bit further in school until a couple years later, when I finally got my own computer at home. Although by then I think I was 11 when I got my first computer at home, which was a Tandy Color Computer 2. It was branded TRS-80, but it was not compatible with the original TRS-80 line. This was a 6809 based computer, and it was fairly popular in the 80s. You bought them at Radio Shack. That was the electronics store. It wasn't like there was a different electronics store to go to. There was Sears, where you could buy a TV and like their rebranded Atari. But otherwise, if you were to like go buy a computer, I think maybe you could buy a Commodore 64 at Sears or maybe some other department store. The main store where you bought computers and computer stuff was Radio Shack. And so that's where my first few computers actually came, from Radio Shack. And it was with that computer where I first got exposed to BASIC. And when I got that Tandy Coco 2, there was literally nothing I could do with it other than I had the word processing cartridge, color script set that came with it. I could stick that in there and I could write. And I actually used that for a few years before I got my first PC to actually type out school papers and stuff, which was a fun journey. And I don't even think I had a game for it when I initially got it. I had 0 games. What I had was BASIC. In order for me to do anything with this new computer of mine, I had to learn BASIC. It was the only course of action that I had available, was to learn BASIC, to go through the manuals that came with the computer, this programming in extended color BASIC with a Tandy Coco 2, and going through there, typing in all the programs that were in that book, and then going back and trying to figure out how those programs worked, and in some cases actually having to debug those programs, because sometimes there were things that were in there that didn't work. So I had to kind of figure that out and learn what things like syntax error meant. When you're 11, syntax is not part of your vocabulary. So that's how it all started for me. By the time I got to college, my only programming experience was on Logo on the Apple II, and then BASIC on my Tandy Coco 2, and then eventually getting my Tandy 1000 HX PC clone, or technically it's like a PC Junior clone, and that had, of course, GW Basic, and eventually I had Quick Basic, QBasic installed on there. We do that, and that was the only programming that I had done, in addition to Logo on the Apple II, which I eventually came back to my senior year. We're talking like 1992 by this point. And Apple IIs, this was an Apple IIe now, which were still in production in the 90s. After you had like 386 and 46 Windows PCs out there shipping, you could still go buy an Apple IIe, brand new. And it ran another version of Logo that actually connected to a breakout box for controlling Lego robotics kits. And so I built and programmed a Lego robot using Logo and be able to send commands, and then also do other things where I could play music that went along with it, and just to create robots, eventually like a capture the flag type robot that all the control code was done in Logo. That's when I started actually using Logo for more than just drawing stuff with the turtle, and really coming up with subroutines and stuff. But that's how I started, so that by the time I got to college as a freshman, that was the sum total of my programming experience. And then getting into college, my initial computer science classes being Modula 2, which is a variant of Pascal, and eventually learning assembly language and C, and then just a multitude. The great thing about the university experience was having the exposure to all these different types of computers, different operating systems, different languages. Scott, tell us about your first programming experience.
Well, so I attended a tiny little country school in Northeast Texas. I was in a graduating class of 16 kids. So it was a tiny school. But spring of 1982, end of my 8th grade year, my school decided that they were going to get on this newfangled computer bandwagon and start teaching the kids about computers. They bought 3 Commodore PET computers, 4032s, in fact. And we had one dual disk drive, big monster of a thing. And we had a printer, and each of the computers had a tape drive. So our math teacher went back to college to take a couple classes so that she would be certified to teach the computer class the next year, at which point she became very valuable in the education community and got a better job at a different school. So we had this bench, this table at the back of our math classroom for 4 years until I was a senior. That had these computers that were otherwise just going to be gathering dust. And I was always really good in math, so I was given permission, if I finished my work quickly, which I always did, to play on the computers afterwards. So yeah, that was great. I loved it. It was like I had my own computer lab. I had 3 computers, and I was able to show some of the other kids things that I learned, some of the sample programs that came with it. My very first program ever was in Basic 4 on the Commodore PET. And it was a word processor, except for it really wasn't a word processor. What it was me writing a program to print a paper by having line 10, open a channel to the printer. Line 20, print to the channel on the printer. And so I just had one line of text for every line that I wanted to be in my paper. And of course I had
Sounds like my Dragon's Lair game.
Yeah, exactly. Except for it was small because I didn't have to write a long paper, fortunately. But I used condensed, and I used bold, and I used italic, or whatever effects were available in the font printing. I used it because it was there, and so that was like my very first program that I remember writing. Later on, I really loved the game show Family Feud, and I wanted to make a Family Feud game. And I remember having, for people who are of a certain age, and you think back to what Family Feud was like in the 70s and early 80s, they had the big, LED, like light board that just had the Family Feud text logo on it. And then
it was a flipboard, actually. It was like the airport flipboard where it had those little yellow and black cards that would flip over. So there was no actual lighting to it. It was reflective. So they'd light. They have external lighting for it, and just like at the airport back in the day, they would flip those cards from black to yellow, and so that's how the screen worked.
I did not realize that. So thank you. Anyway, I wanted to emulate that effect. And so I wrote a little program to print with Petsky graphics, the Family Feud logo on the 40 by 25 screen. And then I had a couple of for loops to, I was like, okay, well, I'm going to have this for loop that's going to reverse all the characters at the top. And then I'm going to have another one that reverses all the characters in the middle with the Petsky graphics. And then I'm going to have another one at the bottom. And I noticed that it was slower. It was visibly slower flipping the characters at the bottom of the screen than it was at the top of the screen. And that was my first experience with the idea that, you might have to optimize programs. And what I realized I had done in the end was that I had a for next loop at the top. So like for I next. And then at the bottom, for I next I. And it was just the difference of having the index variable at the end of the next statement that slowed it visibly down because these machines were so slow, especially compared to what we see today. But never did finish that game. But I had a great looking logo. Anyway, and then I wrote one other program in high school. Because we were very rural, we had a vocational agriculture program that sponsored a livestock show every year. And so normally people would send in their submissions, and then somebody would have to cut and paste all these judging forms together for the judges. Well, I offered, I could write one for you we just type all the information in the computer, it'll sort it, and it'll print all the copies that we need. It'll be great. Except, and it did work. I did get it done. I was able to follow through on my promise. But I think back now to all of the mistakes that I made in that program. just using like Commodore relative files so that I could randomly access data on the disk that I only ever treated sequentially anyway. So there was absolutely 0 point to doing that. And sorting arrays of strings, which was just horribly inefficient in BASIC. I mean, it would literally take hours to run for what was not a very large livestock show, but it worked in the end. So after that, I went on to college, bought myself a Commodore 64 in high school, bought myself a Commodore 128 in college. And yeah, I first programming class was Fortran. And then I actually had 6502 assembly language was my one assembly language class that I got to take. And anyway, and so yeah, basic Fortran, Pascal, Modula 2. I've done Modula 2.
My condolences.
Yeah, I mean, and I've just, I'm to this point today where I get to go back and have fun with my old machines again.
Mm-hmm. Oh, that's great. All right, Tom, how about you? How was your first time?
Well, my first time looked a lot like this. I mentioned that my school bought, they had an entire lab full of Commodore VIC-20s and 64s. I don't know where that came from. I don't know if it was a grant or if Commodore was, giving some sort of a special thing or what. But literally, I sat down and I had no idea what this is. I thought it was just a typewriter with a TV on it. But, at first I'm like blinking at it and I pulled up the manual. And I had about 20 minutes because I got like one lunch break to do this and one free period. And I sat down with the manual and I literally just started on page 1 and just went through the book. And I mean, I got to the point where it's having you print things on the screen by typing commands. And, I'm typing, think, why are these things not arranged alphabetically? It was really slow that first couple of years. I think it was that summer when my folks sent me to College for Kids is what they called it. At the local community college, and I took a typing class and a photography class. Both of those have proved invaluable over the years. Photography, because I'm still using it. I've been playing with this camera all night. It's like I can go in here and I know what these things mean. I know what that means because I took that photography class when I was in like 7th grade.
And again, for some of the younger listeners that may be on here, this was not digital photography. This was actual.
No, it was
film.
on film.
Yeah.
I had a 35 millimeter camera that I had gotten for free from had been donated to our church. I can't thank my folks enough for those 2 classes. That being able to type was a life changer when it comes to a guy who likes computers. And but just like Scott, I went through, I bought my folks bought a 64. I still have that 64 in a box in my closet. It's missing half of its chips because the RAM chips were bad. So I used that to build a Reloaded, which was in this enclosure. And now I have an Ultimate 64 in here. And then later I got a 128 for Christmas, and my folks took the 64 to their office, and I had the 128 and the 1571. And I think I bought a monochrome monitor at a local computer store. So I built a little switch box to switch back and forth between the 40 and the 80 column modes, and I used the pin 6 trick to get 80 column video out. So I had the 128 was the word processing productivity machine for the people that couldn't afford an IBM PC. And but I used the crud out of that thing all the way up through high school. I did all my high school papers on it. I started using it for my church to write down all of our music. So I would compose all of our songs for the week. Would print it out. I'd print out 5 copies of it on my dot matrix printer and give it to everybody. And
that was advanced stuff for back then. Not a lot of folks were doing that.
I had a really cool program, and I cannot remember the name. I think it was called Font Writer, and it had 2 edit buffers. So what I did is I put all of our songs that we knew on a floppy disk. And since you had room for 16 characters in the file name, DOS is over here with 8x3. I could do 6 on a 340K disc, or however big the 1571 double-sided discs were. I could fit a lot of stuff on there. I would sit down there and I'd put all of the individual songs as individual files on the disk. And then I had the big edit buffer. I would go load the single song into the small edit buffer, select everything and copy it and paste it into the big edit buffer. And that's how I built our set for the week. And like, if we could fit 2 songs on one page, or if we couldn't, it was, but yeah. Then there was one time when we had a blackout. So I packed everything up, took it down to my girlfriend's house working on this stuff at her house. Then after it was all done, we played a couple of games on the machine for the rest of the night. But yeah, that's eventually I started programming in C on the PC, and I'll be honest, once I discovered Turbo C++, I really didn't go back. I mean, it was BASIC is my first love when it comes to programming, but yeah, I really, when I fell in love with programming as a discipline and as a practice, was learning C and C++.
Yeah, and also hats off to Borland for having such a good
that
product.
may be the single finest computing product ever made. Was the last version of Turbo C++ for DOS.
Yeah,
it's certainly the most visionary, and you know, yes, the stuff on Windows is great. Visual Studio is a fantastic piece of software, but think about being able to run Turbo C++ on an original IBM 5150. The machine that came out day one was still capable of running Turbo C++ in 1989.
Yeah.
Compared to that Visual Studio 2022, it doesn't run on anything less than a couple of years old. It just won't fit. So yeah, and you could still use Turbo C++ to make software that runs on modern machines.
It's amazing. It really is, and also the fact that was still really a very early adoption. This was in the extremely early days of C++, before you had the standards that we have now, and of course before all the template
STL
libraries.
And all that stuff kind of came later. Yeah.
So it was a very different language back then, actually, especially
which actually killed me when I was trying to learn Arduino, because I'm over here trying to write code on an AVR. And the Arduino Uno's an 8-bit processor, and it's got like 4K of RAM, and I'm over here trying to write classic C style code, with where your strings are really characters arrays, and I'm trying to build it was a little like, basically I'm going to call it an electronic dice. I don't want to disclose what this guy's project was because he might still want to market it, but let's just call it an electronic dice, right? And I'm trying to write all this stuff that works, and I'm like, I had no idea that the Arduino ran C++, that I could just create objects and use string objects.
Yeah, I mean, it's amazing just how small. I mean, how seemingly small that something like an Arduino is. But then you go compare it to that 5150. It's a far more sophisticated device than this big honking piece of metal that that had to have all these extra daughter boards and everything in it. And with this Arduino, it can have like an HDMI output, and it could have a USB input, and you could make it into like a very simple terminal-based computer, and it's just amazing how much power it is, and it's something that we would use all that power to make a small C++ program to make Christmas lights go blinky blinky or something.
Yeah, right.
All right, well, let's move on here. Zero Byte. Let's tell us about your first time programming.
My first program was probably everybody's in this generation. It was on an Apple II, and it was the 10 print your name, 20 go to 10. There was a class at my elementary school that got I guess that was the free Apple II computer that all the schools got or something. But we wrote some programs like it would calculate how many minutes, hours, and seconds old you were, and things like that. And when I got my Commodore 64, like, I actually did write a blackjack game for it in BASIC. I would go through the book and type in the example programs and things like that. Probably some different things out of Compute magazine. Fortunately, a friend of mine was one of the spoiled kids that his dad subscribed to the typed in on a floppy subscription, so we didn't actually have to type it and then spend 4 hours debugging. We did do that one time. We typed in this game, and it was one that had like embedded assembly and data statements, and we got the whole thing typed in, and once it got where our syntax errors were past the point where it had rearranged the character set and you couldn't see what line number your errors were in anymore, we'd have to hit like run stop, watch for that like one frame when the characters went back to normal, but before it like cleared the screen, and catch the line number. And we got it that way, and the game started running. But some typo we had made like just created a bug in the game and the game was unplayable, but it ran. It was really disappointing to have spent a day and get there, and then like we get the floppy disk and we didn't have to go through that anymore. But like I said, for me, I was more playing games than making them back in those days, strictly because most resources, like if I was going through the manual and typing things in, I could follow it. I could, make changes and make the little flapping. I guess Flappy Bird was one of the programs in the manual, but it was the one in the Commodore that drew the ball and the two pet ski things like that, and it went down the screen, and I could make it go up or other things like that. But just certain concepts just never quite clicked well enough that I could replicate it, I could change it, but I didn't like grasp what it was that was happening under the hood. And I think that was one of the things that made it hard to get deeper into things like assembly or other programming languages for me. I certainly was interested in it. And when I got to high school, my senior year, I had one class in my schedule, one slot available, and I decided to take programming, and they let me take the computers 2 class instead of 1 because 1 was like, this is a spreadsheet. This is how to use Lotus 1, 2, 3. So we learned how to program in Pascal, and so then when I got into college, that was still in Pascal here at the time. And so while you're typing, this is, enter student ID number, enter first name. Those are when the lab would come along, I'd have that done in like 5 minutes. And I started writing screensaver modules in Turbo Pascal with just like text because I was done and did that. And that was how I got into a little bit of graphics programming in Pascal with that EVGA, BGA, BGI, whatever they called it.
BGI.
I had no idea about like screen refresh and stuff. So anytime I started doing things, we were blitting rectangles, it would tear really bad. And one of the other programmers and students that did graphics, he was like, "We need to double buffer." So I said double buffer, and it still was tearing, But that was because I didn't know like what VSync was and all that. And like I said, I branched off into just scripting and whatever after that.
But
Me,
and basically with your career wise, like I said, you've moved on to just doing more just direct IT work and setting up networks and things like that.
it's
At
kind of
what
like
point?
programming in a way.
Yeah. So like at what point
Because
did you at some point did you realize that maybe that programming wasn't something that you wanted to do necessarily as a day-to-day job, or is this just that you had the opportunity in this IT management area?
it just sort of happened that way because I actually, when I went to college, I chose mechanical engineering as my major.
Ah.
Like I say, I like computers, I like games, I like programming and stuff, but I always like pictured myself designing, bridges, cars, tanks, whatever. And I got a good bit of the way through that curriculum in mechanical engineering. So I like got through all the weed out courses, all the math, all the calculus and everything. And when I was getting into the core curriculum, it started to dawn on me that the actual career of an engineer wasn't somebody sitting at a draft table making stuff. You're basically making like production schedules, and you're going around making sure that nobody was screwing up,
Yep.
and spending the rest of your time like pushing papers up and down the corporate chain, and you weren't designing airplanes.
Mm-hmm.
And I was like, so and as a default, I switched over to computer science because I went down the college's office and said, give me my transcript. I don't know what I'm going to do, but I'm not going to do engineering. And went over to School of Computer Science because I was like, I like computers. What the heck, And actually, I really have my mom to thank for this because when all this stuff was just starting back in the 80s, was when she went back to college to get her master's in education, and they had a Apple. They were introducing their grad students to, hey, computers are going to be big. And she brought me up to the university one day with her, and they had this little demo. It was just like how to interface with the computer. It was on an Apple II. It had the color monitor, and it was probably the only time I ever saw a color monitor on an Apple II in person. Like the rest of the time, they were always the green ones, And it was like, these are cursor keys. Here's how you move it around, and all that. And she sits me down, and I'm like figuring it out, and it was pretty neat. And that led to her getting me the VIC-20, which led to the Commodore 64. And then when I'm in going to college, I happened to win some money playing video games that Nintendo came by the campus and had a contest, and I was the winner. So like it paid off a little bit, and that was how I bought my 386 in the 90s. And and I did do some programming, and I did it on the Commodore as well. So mission accomplished on my mom's part. And like, well, at least it's not like an Atari where all you do is play games. I did pull out the manual and program stuff with it, but the rest of the time I was playing Jumpman and Mission Impossible and all those other things, Ghostbusters, you name it. I mean, I had discs, stacked this high with stuff. But
it is kind of weird that when I moved from the Tandy Coco 2 to the 1000, when it was actually running DOS and everything, that I did have the ability to have a more productive computer and use more modern productivity tools, but I actually did a much less programming on that because I had such a wider selection of games available by the early 90s. Like 1989, I think, was about when I got that. And so by the 90s, I had all these games that were available that I didn't have to program to enjoy using this PC.
See, I was the other way. I was like, man, I wish I could make Miner 2049er. That would be cool, But I did, I also did use my Commodore 64 for productivity. Like whenever there were term papers in school, I went and bought a printer for it. Eventually, the Oki color one, the black one with the wax ribbon. Yeah, well, I wanted color. I was like, the ad in Compute magazine like sold it to me, so I went and bought one. And whenever I did science fair projects and stuff, the graphics and stuff that were on there, I printed them out from my Commodore. So I did use it for more than Donkey Kong. The career path that I went on, like, it kind of is like programming, because routers, when you set up routing protocols, you're setting up all these little state machines that follow rules, and it might be like only 8 lines of configuration, but it's like what's behind the thing that makes them behave. And you're making this system of things that says, well, gee, this link's not up, so we're going to go this way and around and all that kind of stuff. So it kind of is programming. I never really thought about it that way until just now, but it really is.
Well, I know I've spent a lot of time working on like iTables type configuration, and like we were talking before about DNS records for this www.retrobrewhouse.com, getting that to work and getting all of the getting that domain to work properly. I'm used to having manual configuration of web servers and being able to put in the A records and the C names and all that, because it is more of like a programming thing. And now with the web hosting and the domain registration that I have, because I'm trying to pay as little as possible to do that, so what I have are the easy tools, the square quote easy tools for managing these things, and where I have to cede control of how I do that to this faceless corporation that actually holds my domain and has the real control over how it's used.
I missed the word hostage in there.
Hostage, yes.
Hold my domain hostage.
Oh yeah. Well, yeah, that's my background.
Oh, that's great. Well, thanks a lot for that. So I think now it's time to move on to sort of our final topic of this podcast, and this really cuts to the heart of why we're doing this podcast, and so what we're going to kind of be focusing on from now on. Hopefully we keep doing this podcast. It's been pretty fun so far. The big question is, why are we doing this retro game development or retro gaming, building these retro style platforms, acquiring vintage computers, and why are we doing that now? Because I think everybody who's listening to this is aware of the state of programming now. Again, I always like to point out is here's my magical device that sits in my pocket and can do literally anything.
I have my observation on this is I think this is our generation's version or equivalent to the baby boomers tinkering with cars.
Exactly, yeah.
My dad's generation, they all had the car up on with the hood open, and if they could get a few more horsepower out of it or a little more muscle, that was the thing, because they grew up tinkering with cars and going and drag racing and outrunning the cops around the corner to not get a ticket and whatever. That was part of their culture, and we grew up doing this stuff. That's what we've been talking about. And now, it's not the stuff that's in the ivory tower that costs like $300 a chip, to R&D anything. You can go to Mauser and get a pile of chips and tinker with it.
Mm-hmm.
And so now, instead of dad showing his kid how to tune a carburetor, it's dad showing his kid how to write a tighter loop in assembly in 6502. It's like you can make it where you don't drop as many frames here. You got to watch out for your raster time, all that kind of stuff. And that's what I think really it is. And not only that, but the tools that are available, like if you watch Adrian's Digital Basement or anything like that, you can go get a SD card and pull a 286 out and have a hard drive for it, or XT that you couldn't have. I mean, an MFM drive is just gonna die. You can't really have one, but now you can stick a little chip that's like this big in there, and it makes it come back to life. And that's why I would say retro is thriving so well.
Yeah,
myself.
I think that really cuts down to it. And this is a discussion I remember having on the Commander X16 Facebook group, where we saw a lot of folks were saying, well, why can't it do this and why can't it do that? And it became the cliche after a while, well, I think what you want is a Raspberry Pi. And Raspberry Pis are great. I love Raspberry Pis. Look, I've got one, and it's disappeared on me. Anyway, I had a Raspberry Pi right there. And it does all these things, and it can run Linux and do all this cool stuff. But again, it can like literally do anything, but it's still a very complex system at its heart. And that I compared that into the car world, where it's like, well, Commander X16 is like a Model T. And like if you read Grapes of Wrath, the teenage kid who's on there, who's the one that knows about cars, because everybody else was born before cars were a thing. They grew up before cars were a thing. He's the one that's keeping that Model T running from Oklahoma all the way to California, because he knows how to go in there and tinker it. He's not a mechanical engineer, but he knows enough to keep it running, and that's something that you could do when the machine itself was that simple. It was not easy to operate. And that was the other thing, is that like, again, going back to Grapes of Wrath, there's only like a couple characters in there that were skilled enough to be able to actually drive a Model T, because it wasn't like a modern thing. It wasn't like a Tesla that will literally drive itself for you. But if something went wrong with your Tesla, you'd have no idea of what to do with it.
Case in point, I can tell you what every one of these chips does, because I went through and tested every one of these chips trying to figure out the video problem.
And this is a mini pet for those listening on the podcast.
This is the mini pet. Yeah, this is a modern reproduction of of Commodore's first computer. It's like over here we got your CPU. You get your memory. You've got. But I went through and tested the clock circuits and a couple of other things on every one of those chips trying to figure out the video problem. Do that on a Windows PC. With $1,000 graphics card and an i7 processor, you're not gonna sit here with an oscilloscope and figure out why you're getting fuzzy video on your HDMI port,
or even on a Raspberry Pi for that matter, because it's a system on a chip. It's all internal. Like it's
under a blob of.
I could tell you I did discover a problem. I want to say it was this chip right here was bad. And I was getting checkerboarding on the checkerboards. The checkerboard ASCII character. When I put two of them next to each other, you get where a spot should be black, it was filled in. And it turns out the bit shifter was bad, and that last bit, only under certain conditions, it was staying as a 1 when it should have gone back to a 0. Only in 80 column mode. So I replaced that bit shifter with a new chip, and that solved one of the problems. But I wouldn't have been able to do that on a modern PC.
Oh no,
not a chance.
No, basically you throw it out. So like when this magic device that sits in my pocket stops working, there's going to be one of two options. Either it's working well enough that I could give it to one of my kids to use as a tablet, a gaming device, or maybe as their phone. But then otherwise it's just garbage. It's just going to go into landfill. There's no real fixing it. Like I've replaced a screen. I had an iPhone 4C. I did the iFixit kit to replace the screen on that. It never quite worked well, and still, like, the screen broke on it. I don't understand Apple at all. Like why people like them so much a lot of the time, but but still it was. I mean, that was not too bad enough because there was a bunch of little hookups, but all these little tiny screws. I didn't need to wear glasses back then. I don't know if I'd be able to do that now if I had to replace the screen on a smartphone. But if anything else goes wrong, no, there's nothing. There's nothing to do, and it just gets into our larger culture of, well, we'll just throw it away and buy a new one, because like a Raspberry Pi in normal times it's $35 to replace that, or even cheaper for something like a Pi Zero. But then again, if something goes wrong with it, there's no debugging it. You just throw it out. If you're not Linus Torvalds, if there's a problem with the Linux kernel, you don't know how to fix that. Where do you start with the Linux kernel? It might as well be a total black box. But if you look at, say, the kernel of the Commander X16, or even on the vintage systems, or in these other modern retro systems like the Mega 65, it's understandable at a basic level. And then if you look at even something simpler like an Atari 2600, it is so simple. I mean, just dead simple, that it becomes then sort of an intellectual challenge of how do I make this thing that is like the digital equivalent of a barrel hoop that you push along with a stick. How do you make that play a game? And that's what I think it's the interesting challenge for that, and that it provides the constraints of what you're going to be able to create for it. So like when I made Chasefault for the Commander X16, it's like, well, I know exactly how many resources I have. I know what kind how big of a map I can have, what kind of resolution I can have, a color depth for all these pixels, and I know, like, here, I'm just going to have these 16 by 16 pixel sprites and tiles. There's only so much I can do with that, and doing like, and each of them being only 16 colors, that I'm not like a professional artist or even a graphics designer, but I'm skilled enough that I can make something that looks, acceptable in this zone. I can make an Atari 2600 sprite that's as good as literally anything that anybody created for, say, Activision, because there's only so much you could do. So yeah. It's because of those constraints that at least for me personally, make this an interesting hobby, and certainly it's like an intellectual pursuit at that point.
David Crane said something similar to that in GDC talk that he did. He said that the limitations of the 2600 were its strengths, because so much being done in the CPU, when the CPU is the video card. It is, when it's everything, it's what allowed the system to like do things that they didn't intend for it to do when they built it. Because it gave the full, it's harder to program, but because you have that freedom now, that gave them the ability to make it do anything they could imagine. And they designed it to play Pong and to play combat. Yeah. And that's it. That's why the primitives in it are the way they are. And then somebody said, well, if you change colors a bunch of times, you can make rainbows that scroll. And then, most Atari games have scrolling rainbows somewhere.
Yeah, it's true.
It's hard to make it not do a scrolling rainbow. And that's the thing. That's the dirty secret of it.
Yeah. Well, it's like, the whole idea that it can only show like 4 different colors on the screen at any time as far as the chip's concerned, but that's only at any given moment. And you're changing it in the future, it forgets that it 2 raster lines before the background was a different shade and the sprites were in different places and different colors. It doesn't know. It has no memory, and so you can make it play all kinds of cool dude stuff that doesn't look like Pong or combat.
And that's the other thing, like, interesting, and I think we'll talk about more of this. I plan on doing a future episode. It might even be the very next episode. We're going to look more at the Atari 2600. But because of the sheer simplicity of it, you could have, like, we think about, like, Mike Tyson's Punch-Out as being some of the most impressive sprites on the NES because they were just so huge. These big detailed sprites for these enemy fighters. And the fact is that they wouldn't look as nice in the Atari 2600, but it would be a single 8-bit register. It would be all you would need to make one of those a sprite of the same size on on the 2600. It's just crazy.
You couldn't even hold the entire display in memory in the 2600. You had to race the beam to write everything.
There's no video memory. There are 6 or 8 registers, 8-bit registers. So your video memory is measured in a handful of bits.
So a lot of the things that became tropes in the gaming industry, like you ever play pole position? You notice how in pole position when the road turns, like it doesn't turn starting at the top like you'd expect. Like the entire road just starts to twist all at once. Is because that came from racing the beam way back when those games were first being made, and the arcade did it, the Atari did it. They brought that over to the Commodore.
And the NES has like just barely enough video memory to hold everything that you see on the screen at one time. And then it has since it has like a fast ROM chip holding everything, it can just bring stuff into that video memory as it needs to be there. It's really, it's just stuff like that. You're showing your game is just a small window on what this system can do, and everything is just coming into that window at just the right time. It's not like okay, I have a video, like an MP4 video file that I come play a clip out of, and I call some Python library to queue that up. That you just don't have that.
You say like png.load, png.color shift,
right,
png.save. 3 lines of code.
One of the things for me that I just love so much about retro is that we're kind of living in this golden age of retro. I mean,
we really are.
It wasn't retro, but
it wasn't cool 20 years ago.
Exactly. But today, first of all, we all have computers that are powerful enough to run state-of-the-art emulators for our platforms of choice. When I did Petsky Robots for the 128, I did not own a 128. I did everything in the Vice emulator. And then on top of that, we've got companies like, RGL that have released the C64 Mini and the C64, and now the A500. So I mean, those are still emulation, but they're specialty emulation platforms. And then on top of that, we've got the Spectrum Next, and we've got the Ultimate 64, and we've got the 64 Reloaded, and everybody and their dog, it seems like, is coming out with either a recreation of some classic thing, or you've got Stephanie with the Phoenix line, and you've got David Murray with the Commander X16. I mean, this is a great time to be working in something like that is simple enough that you can hold it all in your head at one time. You don't have to, refer to, the shelves full of books that I have on this opposite wall from me to do, Windows kernel development or something like that. You've got 64K or 128K, and that's it. And so you make things fit, you make things work. And there's so many options to play it today that just didn't exist 5 years, 10 years, 20 years ago.
Yeah. And I think that
I just pulled up 3 different computers in one box.
The Mister, which is what Tom is showing. If you're watching the video, you can see him just bring up all these different cores for the Mister.
Name an 8-bit computer.
I know, seriously, it's amazing.
They're all in here. I mean, look at that.
It's so great. Yeah, it is. It's quite a time to be alive, and I think also it goes to when you're talking about that golden age, and I think it is driven also by the homebrew scene. It's not just folks wanting to play these old games. That if somebody wants to create a game, people think about Well, I'd like to create a game, and if you wanted to create a game for a modern PC or a console, you'd have to have you have to have a team of like 100 people to do that. You have to have model artists, all these things. You'd be working on like one small part of it, like maybe this one renderer in the engine, or you'd be working on this one little part because it'd be a full-time job just to make this one small piece of a modern AAA type game. And for these 8-bit machines, just like for the Atari 2600, it was one person that would make each of those games. And even by the time the NES came around, it was you'd have a few more people, but still a lot of the computer games, a lot of the Spectrum games and the Commodore games were still written by a handful of people, like never more than like 2 or 3 people. A lot of these big Commodore 64 games like Ghostbusters, it was pretty much like one guy that made Ghostbusters. It's amazing.
This one developer was talking about when he was a teenager, and he's like, yeah, I wrote this game in a couple of weeks. He was porting like Outrun or something like that to the Commodore 64. And it's like, he wrote the port in a couple of weeks by himself. Did the music, did the sound, did the graphics. I'm like, it takes 3 years to develop a AAA modern game for consoles. 3 years
if you're quick.
For something on the scale of Call of Duty.
Yeah.
And this kid's over here like, yeah, I started over Christmas vacation, and by Easter I had a check. We were done.
And that's the thing, and it was also kids. That the fact is that, like, yeah, I mean, during this era, I was a few years younger, so I wasn't quite old enough to understand how to do that. But these were still literally kids, a few years older than me, that were getting games published and put out for these 8-bit systems. And it really wasn't until the late 80s and into the 90s where game development became more of a large professional thing, where it wasn't just like, here's some publisher that is going to go pay this kid for that game. You're going to have a Sierra or an Acclaim or EA actually start having like dozens or maybe even close to 100 people to start working these games, because they had more sophisticated graphics at that point, so you had to have all these artists. And then when PCM sound became viable, and high capacity hard drives and CD-ROMs and things, then you had to have voice actors to say to narrate all this stuff. And so now you're hiring all sorts of people to make these games.
When the guy that created Stardew Valley did it by himself in about 2 years, and that's an anomaly now.
Yeah.
Yeah,
that's an anomaly in the industry.
AAA titles today, you're looking at dozens or even hundreds of man years of effort to accomplish that.
Yeah, it's just not a thing. But you can do that. You can make you could make a game for the Commodore 64 yourself that is. If you're an experienced enough programmer, if you've learned 6502 assembly, and you learn the basics of how the Commodore 64 works, you can create a game within a year in your spare time that's as good as any of the games you ever played for the Commodore 64 back in the day.
And better than most of them.
Yeah, especially since you have the time.
Download the C64 collection. Like, what is it, Assembly 64? 90% of that stuff is just trash.
Just awful.
Even by the standards of the time, it's trash.
And people were paying $10, $20 in like $1983, $84 for those things. So pretty much now, what like now, if I had to buy a new console game, it would be $60. It was pretty much that big of an expenditure for these games. That was like one kid, literally a kid, wrote a game and it's utter crap, and you just spent $20-$30 on it, and you're not getting that money back. So you're gonna make archival copies for all of your friends to store.
Copies.
Yes. So to make sure that at least that work isn't lost. So I think that's a big reason of why we're here and why this podcast exists. So I just want to thank all you guys here for joining me here on the very first episode of Retro Brewhouse. I think it's been a lot of fun. We've gone even longer than I expected to go. This is a really great conversation. So I thank you so much for joining me.
Oh, no problem.
All right, and now
It's been great being here.
yes, indeed. All right.
To do some more.
It's closing time at the Retro Brewhouse, so I want to thank you for listening. This podcast was hosted and produced by me, Matt Heffernan, and our co-hosts today were Scott Robison, Top Wilson, and Zero Byte. The opening theme for Retro Brewhouse was written by Zero Byte, and the closing music you hear right now is Desperate Confrontation by Joshua J. Salazar. Our biggest thanks go out to our supporters on Patreon, especially Andrew C. Young, Electron Star Collapse, Eric Floor, Jimmy Donsbo, Leo Payson, Sevej, and Vince Valenti. If you want to support this podcast, you can join our Patreon community at patreon.com/slidingmat. Or you can visit our webpage at www.retrobrewhouse.com and get links to Patreon and all our social media profiles, as well as linking for subscribing to our podcast on your favorite app. This has been episode 1 of Retro Brewhouse, a podcast from Slidey Games. We'll be back again soon with more of the latest developments on obsolete technology. Until then, bye-bye.